Now, come guys to the third part of the lecture, which is the electrical potential of the nerve. How the signal will be moving from one part to another part in the nerve system. We have something we name it as electrical potential of the nerve. This is the nerve. The inside the nerve have a negative charge, mostly negative charge, and outside the nerve is a positive charge. So there is a potential difference between them because you see it's positive and negative. So there's a potential difference between them. So across the surface or the membrane of every neuron is an electrical potential difference due to the presence of more negative ions inside the cell membrane and more positive outside the cell membrane. This potential difference is just about between minus 30 millivolt to minus 90 millivolt. And because there is a potential difference, that means the cross membrane, that means the cell will be polarized. So when there is a potential difference, inside is minus and outside of the cell is positive, it will be, we name it as a polarization one. So you can see here, this one is polarized because it's just inside minus, outside minus. When you're measuring it, you'll see it is around minus 80 millivolt. When the membrane potential become more positive, that means inside will be more positive. That means it will be depolarized. Okay, so for example here, it will be depolarized because of the just like the inside of the cell membrane. When you said negative, inside the cell membrane is negative. When you said when they become more positive, that means inside become more positive. So it will be, we name it depolarized. We have another condition, we name it hyperpolarization. When inside the cell membrane, it will be more negative than the normal. So this is negative, which is normal one. When it's being more negative than the normal, we'll name it as a hyperpolarization state. So we said there is ions inside and outside, positive and negative. What is the types of ion we have it? We have a K plus, we have organic anion, and we have the Cl, and you have Na as well. So up from here, you can see the big letters, which mean high concentration. So the K, the potassium and the organic ion, potassium positive, organic ion negative is the high concentration inside the cell membrane, while the chloride and the Na will be outside the cell membrane. So the chloride and which is the chloride and the Na outside, the organic ion and the potassium inside. And you know that the positive charge, sodium and potassium, and the negative charge will be the chloride and the organic ion. How many channels we have to make this passage? We have ion channel that mainly allow K plus to pass are called potassium channels. And we have ion channels that mainly allow Na plus to pass are called the sodium channels. Okay, the question is, what about the chloride and the organic ion? So we'll talk about it in the lecture, inshallah. In terms of we have another things. We name it as a Na plus, K plus pump. And this pump is just to keep the concentration of the ions of the K plus outside the cell membrane and keep the potential of the Na inside the cell membrane. To keep the concentration of the K plus inside the cell membrane and to keep the concentration of the K plus outside the cell membrane. So if there is any low concentrations happen, so it will be maintained by the activity of the protein called the K plus Na plus ATP base. So this one will be make the concentration between Na plus and K plus is just like outside and inside clearly. This is the end of part 3, section 1. Later, I will send you the part 3, section 2, which is talking in details how the action potential happens. Thank you very much.